Okay, 19, 23, and 25. 19. Roughly sketch the shape of a cubic polynomial. Well, I know first of all a cubic polynomial is going to do something like that, right? It's going to have two terms in it for a third degree. So let's see what we know here. We know 0, 3 is on the graph. So 0, 1, 2, 3. I know f prime at 0, the slope at 0 is 4, so it's going to be about that steep maybe. At 1, it's 0. So since it's increasing here, it's got to be up here. The slope is 0. F prime at 2 is negative 4/3. So it's got to be going down like that, negative 4/3. And f prime at 4, out here at 4, somewhere, somehow, I don't know where it is on the y-axis, I know that the slope is 4. So you kind of get a feel for this graph. It's going to do something like this. Let's do this. Let's do blue. It's going to come up here, go through there, come down, and turn around and go back up. So it's just a cubic. I don't know how far down it goes or anything like that, because we're just trying to do a rough sketch of it. Alright, so 19, let's do 23. Find a formula for the derivative algebraically. Okay, so 23. I want to know what is, if, oops, it's n of x, not f. N of x equals 1 over x plus 1. So if I want to find it algebraically, I can use a rule, but the shortcut rule, but let's do that afterwards. So the algebraically, n prime of x is the limit as h approaches 0 of 1 over x plus h, plus 1, minus 1 over x plus 1 all over h. So that's the limit as h approaches 0 of, if I get rid of the parentheses on top, the 1's cancel, so I get 1 over x plus h minus 1 over x over h. And I'm going to go ahead and multiply top and bottom by what to make this a little bit simpler. Let's clear the denominators on the top. Let's multiply the top by x plus h times x and the bottom by x plus h times x. That's going to get rid of my fractions in the numerator, which is what's making this kind of messy. So if I distribute, I get x minus x plus h all over h times x plus h times x. And the x's cancel, and that becomes a negative h on the top, right? Minus the h. And so then that's going to cancel with that h. So I get negative 1 on the top. On the bottom I get x plus h times x. And as h goes to 0, that becomes a negative 1 over x squared. Okay, so that's my formula for h, that's n prime. Now if I use the power rule, I can write this as if I use the power rule, I get negative 1 x to the negative 2 plus, and this is x to the 0, right? So that's 0 x to the negative 1, which of course is 0. So that gives me 1 x to the negative 2, or negative 1, which is exactly that guy. Okay, so we can look at them both, look at it two different ways. And 25, I chopped off part of the problem, so let's see, between which pair of consecutive points is the average rate of change the greatest? Well, the average rate of change is the slope of the secant line, so I want to try to see which one of these secant lines is the greatest. And it looks like from C to D. From C to D, the average rate of change is greatest. So remember the average rate of change, the slope of the secant line. Okay, so it's, f of b minus f of a over b minus a is the typical formula we've used. Where is it closest to 0? The flattest from b to c. Okay, so that's A, part A and B, and then B, which is not on my picture here. It says between which two pairs are the average rates of change the closest? It looks like this one here and this one here are the closest. So from A to B and C to D. Okay. Make sure that you're really clear on what an average rate of change is. Because if this is my position, this is my time, and I go like this, the slope of the tangent line is my instantaneous rate of change, or my speed. So I'm going much faster here than I am here. And I'm slowly getting faster and faster, right? But what's my average rate from A to B? Well, that's how far did you go? You went S of B minus S of A. That's the distance you traveled divided by the time. Okay, that is the slope of the secant line.